Hey, today we're going to move on from congruent triangles. We're going to start talking about similar triangles. So things that are similar aren't exactly the same, but they have some characteristics that are the same, and that sort of holds true for triangles. And so if two triangles are similar, we know a couple things about them. We know that their corresponding angles are congruent. And so if I look at these two similar triangles that I have the similarity statement up here. Notice the symbol is different than the congruent symbol. It's just a little squiggly. But the angles should match up just the same as they did when we had congruent triangles. So if I look at M and Q, they have the same amount of markings, so they're congruent. L and R have the same amount of markings, they're congruent. And the same is for N and P, have the same amount of markings. So I have all corresponding angles congruent. The difference here is that our corresponding sides are not going to be the same size. You can see by how they're labeled, these triangles are not the same size. But what we need is the corresponding sides to create the same ratio, the same fraction. And that would mean that all three fractions are equal, which would create a proportion. So I'm going to match up the smallest side with the smallest side, the biggest side with the biggest side, and then the ones in the middle, and I'm going to write those three fractions. So I have 2 over 10, 3 over 15, and 4 over 20. All three of those fractions simplify to be 1 over 5. And since all three of those fractions are the same, they're all equal, we say they're in proportion, and we could say that the corresponding sides create the same ratio. And these two triangles are similar. And that 1 over 5 value is what we call a scale factor. So the fraction that all of the corresponding side fractions simplify to be, this 1 over 5, is the scale factor between these two triangles. So just like when we had congruent triangles, when we have similar triangles, there are three kind of shortcuts to show they're similar. When we had our congruent triangles, we had 5. Here we have 3. The first one is the angle-angle similarity postulate. And we just put a little similar symbol just so we can differentiate between the congruence and the similar. So if we know that two pairs of angles are congruent in two triangles, two pairs of corresponding angles are congruent, then we can say those triangles are similar. Before, we're not allowed to say that they're congruent, but we can say they're similar. So in these two triangles, one angle is 29 in each of them, and one angle is 76. So we know that those two triangles are similar. We also have the side-side-side similarity theorem. And so if we don't know anything about the angles, but we do know that all corresponding pairs of sides create the same fraction, then we know those triangles are similar. And these are our two triangles from the last slide. So we know if we write all the fractions, it'll simplify to 1/5. And so we could say these two triangles are similar by side, side, side. And last, we have the side angle side. So we have two pairs of sides that we know create the same fraction. So I match 4 with 16, because those are the two smaller numbers in each of the triangles. 5 over 20. Those both simplify to be 1/4. So we have two pairs of sides that create equal ratios, equal fractions. And then in between those sides, we have an angle that is congruent that gives us side angle side. So we'll do a few deciding if these triangles are similar and by which theorem. Well, I have a way to do that, and I sort of start by listing the options. There's 3 options, and so right away, when we don't know anything about the sides in these triangles, we know that they can't be similar by side, 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 or side, angle, side. We don't know anything about the sides. We do know that angle T and angle C are both 100 degrees, and we know that we have vertical angles here. And so we have two pairs of congruent angles. That's what angle angle is. And so we can say that these are similar by angle angle. And then we're going to finish the similarity statement just like we did with congruent triangles. So if I call this STU, I need to call the other triangle SCD, because T and C correspond. They're both 100 degrees. Let's try another one. Again, I like to list the options: angle, angle, side, 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 angle, side. Here I know one pair of angles, the vertical ones, but I don't know anything about angle G and F and K and L, so angle angle's out the door. I also don't know anything about segment GF and segment KL, so side, side, side's not going to work for me either. So I need to check to see if my ratios of these sides are equal. So 70 is the bigger side in this triangle, 182 is the bigger side in this triangle, so I'll write that fraction, and I'll do 65 with 169. Both of those fractions simplify to be 5/13. If you don't have a calculator that can do that with you, you can just check to see that their decimals are the same, and they are. And so that means those two sides are in proportion, or those two pairs of sides are in proportion, and we have side, angle, side. And so since we called this EFG, we're going to call the other one EKL. EF and EK were both the bigger sides in these triangles, so EF and EK correspond in the names. We'll do a couple more together here. Again, my process, list the options. It also helps you in making it concrete that you know what the options are. I don't know anything about the angles in these two triangles, so angle, angle, and side, side, not an option. So we just need to match the side lengths up, the smallest in each and the largest in each, and then the medium in each. And we'll write those fractions. And again, all of our fractions simplify to be the same thing, 5/13. And that's our scale factor, which we'll talk about in the future a little bit more. And so these two triangles are similar by side, side, side. And we'll name the other triangle RST. GF is the side in our triangle that's the middle size, and so RS, our middle size, goes first. And the last one we'll do together. This time we have a little bit of an overlap, so we actually have, for the first time, the reflexive property with angles. Angle E belongs to the big triangle here, and it belongs to this little triangle. It's going to be the same size in both, so we can say it's congruent in both. That's the reflexive property for angles. Let me list my options. E is the only angle we know anything about, and so angle angle is not going to work. VU and CD have no length labeled on them, so we don't know anything about those sides. So side, side, side won't work because we need to know how long all the sides are. So we need to check to see if our sides are in proportion. So in the small triangle, this side's 45. In the big triangle, it's 53. The small triangle on this side is 45. And then this whole length, we just add these two pieces together and get 54. And you could probably tell right away that 45 divided by 53 and 45 divided by 54 are not exactly the same. They're pretty close, but they're not the same. And so these triangles are not similar. So I want you to give these two a try, and we'll go over them in class. Give them a shot. Do yourself a favor, and for each of them, write the 3 options and see which ones you can eliminate. If you have side lengths, make sure you're writing some fractions. And if you have questions, we'll talk about it in class.